Hi dear students, welcome to another class of physics. Today we are going to discuss the 9th standard physics, that is the chapter name is motion. We are going to our balance portion of this chapter, that is graphical representation of motion. What is that? Graphical representation of motion. Graphical representation of motion. Graphical representation of motion. In the last class, we discussed what is motion and what are the main technical terms related with motion. That is distance and displacement and speed and velocity, acceleration, etc. Okay, today we mainly focus on the topic of graph, that is graphical representation of motion. The graphs related to motion. In our everyday life, we observe several graphs in televisions and in other situations. For example, observe the given graph. Observe the given graphs. One is related to the increasing population and the other performance of a cricket team. Then what are the information linked in each graph? Can you say? What are the informations linked in each graph? First graph, if you observe the first graph, there are two quantities. One is population and other is year. In the x-axis, year is depicted, and in the y-axis, population is depicted. And this graph shows the relation between year and population, the growth of population in each year. And graph 2 shows how many runs the team scored. The graph 1 shows how many runs the team scored in each over. That is the relation between runs and over. That is the graph, other graph. Next is second graph. Then what all information do you capture from each graph? From graph 2, we can understand several things, like how many runs the team scored in each over and which is the best over. Similarly, we can capture other informations from the graph 1, that is the rate of population in each year. In each of the year, how is the graph is going on? It's increasing or decreasing. That type of information can be captured from each of these graphs. But here we are mainly focus the graphical representation of motion only. Okay, here we are going to discuss about the graphical representation of motion. Then how can we depict graph of a motion? In the same way, can we represent information related to the motion of an object through graph? For this, we should know some basic facts about the graph. For this, we should know some basic facts about this graph. What are they? What is a graph? I can represent the graph on the board like this. We can represent graph using two lines. This is known as horizontal line and this is known as vertical line. Using two lines, we can represent a graph. Simply we can represent a graph, and it is represented by letter x, and in this and it become x dash, and here is represented by O, and here is vertical line can be represented by letter y, and here is y dash, and x dash is known as x axis. and y dash, the line y dash vertical line is known as y axis. You already learned in the mathematics. Okay, that is the horizontal line, that is known as x axis, and the vertical line, that is known as y axis. Where the horizontal x axis and y axis are intersect, that is known as point O, that is known as origin. That is known as O is known as origin. All the measurements are starting from this origin into x axis and y axis. All the measurements are starting from the point origin O. Okay, and from this figure we can understood that this is a two-dimensional diagram. This is a two-dimensional diagram. It can be depicted connecting two values. One is on the x-axis and other is on the y-axis. Okay, this can be depicted connecting two values. One is on x-axis and other is on y-axis. A graph will have two axes. We already said that. One is x-axis and other is y-axis. Okay, then the axis towards the right of the origin as positive. The axis towards the right from the origin is a positive. Okay, for the x-axis, and to the left of the x-axis is known as, is as taken as negative value. Similarly, okay, that is into upward direction we take as positive value, in downward direction we taken as negative value for the y-axis. OY is taken as positive and OY dash is taken as negative value. These are the basic facts you have to understand from for a graph. Okay, then what is the use of a graph? We can depict the relation between quantities using a graph. We can depict the relation between quantities using this graph. Okay, based on this, equations connecting them can be formulated. Based on this, we can formulate equation connecting with the motion. Okay, that is, gaining information using graph is more simple than obtaining by mathematical calculation. If you find the informations using mathematical calculation, it is very difficult. But when we use a graph, we can gain information very quickly and easily. That is the main benefit of a graph. Okay, then how can these uses made be practical? That is why we are going to see how can these uses be made practical. That's why we want to understand what is a graph, how to draw a graph. Basic things I explained here. What is that? One graph have x-axis and y-axis. Mainly we are focusing in this chapter two type of graph of motion. One is distance time graph, that is position time graph. Distance time graph or position time graph, distance time graph, and second is velocity time graph, velocity time graph. These two graphs are we are going to study in this class. One is that distance time graph and other is velocity time graph. First we are going to discuss about distance time graph or position time graph. How can we draw a distance time graph or position time graph? Okay, observe the table given on the screen. To draw this distance time graph, we want to take time on x-axis and position or distance on y-axis. First we want to draw in a graph paper, that is, here is x-axis and here is origin and here is y-axis, y. And in x-axis we taken time, and in y-axis, on y-axis we taken as distance or position. This is known as distance time graph. If we take time on x-axis and distance on y-axis, this graph is known as distance time graph. Okay, then using some values we want to draw a graph of an event of motion. For example, on a graph paper, draw this figure, that is taken x-axis and y-axis, and x dash, that is x-axis, and y dash, that is y-axis. Okay, here x-axis can be used for marking time and y-axis for position. Make the values given in the table. Then just draw a graph using this table. Listen here. The table is given the position, the time of object starting from 0. That means the value of x-axis, value of origin, that is also 0. In y-axis, value of origin is also 0. That means the time is starting from here 0, and another time is 1 second based on the table, and 2 second, then 3 second, like that. And what about the position? Y-axis, okay, distance or position. Then here is 0, first position is 0, and second position 1, 2, 3. These are the values given in the table. Then we want to depict the graph like this. How? First, for the time 0, position is 0. Then we mark here. For 0, position 0. Time 0, position also 0. Here is the point. And second value, that is for time 1, position is also 1. That means here is 1 and here is 1. Here is the point. We want to mark point here. Then for the third value, that is for the time 2, the position is also 2 meter. That is this. Here is the value. Okay. And third value, that is 3 for 3. Here is the value. If we join in these points, we get a line graph. That is, this is the method to represent graph. Okay. Using a table or values of time and position or distance, we can depict a graph like this. That is, this is a position or distance time graph, and this is a straight line graph. This is a straight line graph. Okay. Another table is given in the screen. Using this table, then we want to draw a distance time graph. Then I said here time is marked on x-axis and distance is marked on y-axis. Then we can draw like this. That is, x-axis, time is on x-axis, time is on x-axis, time, unit of time is second, and distance or position, that is in meter, on y-axis. The first, we want to correct the scale of the gas. What is scale means? Here origin is 0 and here is 1, then 2, 3, 4, 5, like this. Then how to value 6 up to 6? We have the value, that is 6. And here is scale is, what is the scale of x-axis here? Scale means, here is the, in the graph paper you can observe this is 1 centimeter. X-axis, here is 1 centimeter and here is 1 centimeter. This is also 1 centimeter. All these values are 1 centimeter. That means a scale means scale here x-axis. X-axis is 1 centimeter. How much is the value? That is 1 second. Here is 1 centimeter. That is also 1 second. Here is 1 centimeter. That is also 1 second. This scale must be equal. That is the properties of a graph. If the scale is different, graph is not correct. all this scale must be, all this 1 centimeter must be equal value. If you drawing a graph, all the 1 centimeter should be equal. That is known as scale. X-axis, that is 1 centimeter. How much 1 centimeter? X-axis 1 centimeter is 1 second. That is scale. And then if you plot the values on y-axis, that is based on the table, that is here is 0, then 2, then 4, 6, 8, 10, 12. Okay. Then here, what is the scale of y-axis? Y-axis, scale of y-axis can be represented like this, y-axis. And here is 1 centimeter, not 1 meter. Here 1 centimeter is 2 meter. 1 centimeter, that is equal to 2 meter. And this is known as scale of a graph. Scale, x-axis 1 centimeter is equal to 1 second. All the 1 centimeter should be equal to 1 second. Then in the case of y-axis, all the 1 centimeter should be equal here 2 meter. That means the scale must be equal in every graph. Okay. Then how to draw graph here? Based on the table, here for the time 0 second, we have the position distance also 0 meter. Then for the time 1 second, here based on the graph here 2 meter is the position of the object, and for this 2 second position of the object is 4 meter, and 3 second position of the object is 6 meter. For the 4 second position of the object is 8 meter. For the 5 second position of the object, that is 10 meter, and for the position of the object at 6 second is 12 meter. And if we join in these points, we get a graph, line graph like this. And this is also a straight line graph. It is a straight line graph. This is distance time graph of an object. Okay. Then what should be understood from this graph? What you understood from this graph? What are the things you have to capture from this graph? The position time graph regarding the motion of a object is given. Then we can find out the distance traveled by this object at different times. From this graph, we can find out distance traveled by this object at a different time. For example, from this graph, how to find out the distance traveled by this object in 3 seconds? For that, we want to draw a perpendicular line from 3 seconds to the graph like this. Then also draw a perpendicular line to the y-axis. First we want to draw from x-axis a perpendicular line from the x-axis to the graph. Then where this perpendicular line meets, then draw another line to the y-axis which is perpendicular to y-axis. Then we can obtain here where the point meet, that is 6 meter here. That is the distance traveled by this object in 3 seconds. How can we find out? How can you find out the distance traveled by the object in 3 seconds? First you draw a perpendicular line into the graph and draw another perpendicular line to the y-axis. Then where will the perpendicular line meet, that is the position or distance traveled by this object in 3 seconds. Okay. In other case, what is the time to cover this object 10 meter? Then how can we find? Draw a perpendicular line from 10 meter to the graph. Then where does it meet? Then draw another line to the x-axis perpendicular line. Then where will the point will get 5? That means to cover 10 meter, this object take 5 seconds. This object take 5 seconds. That is the method to find out different values using another value. That means it is the relation between two quantities, time and distance. If you find out the distance with respect to time, then we can easily find out like this. To drawing perpendicular lines. Do you understand? The distance graph can be employed under various conditions where objects move with uniform speed, non-uniform speed, and remain at rest also. Okay, we know that when the object travel equal distances in equal interval of time, we can say it moves with uniform speed. Okay, we already learned that. What is that? If an object moves with equal distance it covers equal distance in equal interval of time, then we can say that that object moves with a uniform speed. Then here I draw one of the, here I shows one of the graph related with the uniform speed. Then how can we say it is a graph of a uniform speed? That means here if you observe, in 20 minutes this object traveled 10 kilometer. Then next 40 minutes travel 20 kilometer. Then 60 minutes travel 30 kilometer. That means this object cover equal distances in equal interval of time. Here is equal interval of time means 20 minutes. Okay, 20. Difference is the scale of the graph, that is here scale of the graph. Scale means here x-axis 1 centimeter gives, here x-axis 1 centimeter gives 20 minutes. Okay, and here y-axis 1 centimeter gives, y-axis 1 centimeter gives how much? 10 kilometer. 1 centimeter is 10 kilometer. All 1 centimeter is 10 kilometer. That means here the object travel equal distances in equal interval of time. That's why it is a graph of uniform speed. Because here the position of the object increases with the increasing time. The position or distance of the object increases with increasing time. That's why we say that this distance time graph indicate uniform speed of an object. That means for distance time graph, the straight line graph indicate uniform speed of an object. It shows uniform speed of an object. Okay, if the graph is like this, what is the relation? If the graph is like this, then what is the relation? It is not a uniform speed, it is non-uniform speed. This distance time graph here depicted that is, it is a representation of non-uniform speed because it is not a straight line. In the case of distance time graph, if the graph shows straight line, then it shows uniform speed. If the graph is not a straight line, that means it shows non-uniform speed. The graph indicate non-uniform speed. Okay, from this using distance time graph, we can also say like that it is also uniform velocity. We can say like we can say also it is a uniform velocity, where here distance changes to displacement. Okay, if the distance and displacements are equal in this event, in this motion is, if distance and displacements are equal, we can say that it is also uniform velocity. This object moves with a uniform velocity when if the distance and displacements are equal. Okay, then here if this uniform velocity, that is it is also straight line. Okay, for the uniform velocity it is also straight line where distance and displacements are equal, then we can say that the graph, this motion of the object is in uniform velocity also. Uniform velocity when if the distance and displacements are equal, then we can say that this object moves in uniform velocity. Okay, then how can we find out? How can we find out distance traveled by this object at a particular time interval? How can we find out distance traveled by this object at particular time interval? That means here we already learned that here using the time, this is a time interval, for example between the 40 minutes and 60 minutes, how much distance traveled. Then first we have to draw a perpendicular line to the graph and again extend this line, perpendicular line, to the y-axis. Then we get one point here, and for 60 minutes we also extend a perpendicular line to the graph. Again it is another perpendicular line to the y-axis. Then we get another point here. Then here what is between the time interval 40 minutes and 60 minutes, what is the distance traveled by this object means we take like this. Then distance covered by this object means 30 minus 20, that is 10 kilometer. Okay, 10 kilometer is answer. Then another problem is what is the speed or velocity of this object at this particular time interval? How can we find out speed or velocity of this object at this particular time interval from this distance time graph? How can we find out the speed or velocity of this object at a particular time interval? Imagine I take the first time 40 means taken as t1 and 60 the last time, that is taken as t2, and here position I taken, first position is taken as s1 and second last position is taken as s2. This is initial position and this is the final position s2. Okay, then what is the equation of velocity or speed? We know that speed is equal to distance by time. We already learned that equation of speed is equal to distance by time, and here speed can be represented letter v. Then how can find out speed of this object from this graph between this time interval t1 and t2? How can we find out speed of the object between the time interval t1 and t2? That means here distance means this is the distance. That means s2 minus s1 is the distance. In the first case we 30 minus 20 like that, s2 minus s1, that is the distance, s2 minus s1 divided by what is the time interval here, that is means t2 minus t1, t2 minus t1. And if we join this line to this perpendicular line, then we get one point here also. Okay, then if we mark one of the letters here B, A, and here is B and here is C, then what is S2 minus S1? S2 minus S1 is equal to CB, that is V is equal to CB divided by, then what is T2 minus T1 here, that is AB, CB divided by AB. That is, we get a triangle here. If we divide the side of this triangle with this triangle, then we get the speed of this object at this particular time, between this time at the particular time interval. What is that? If you find out this, if we take the ratio of CB and AB of this triangle ABC, then we get the speed of the object at this particular time interval. That is a method, or V is equal to S2 minus S1 divided by T2 minus T1 is another method to find out speed of the object at this particular time interval. That's why we want to calculate the speed. Okay, we can also plot the distance time graph for accelerated motion, that is non-uniform, for non-uniform speed. For example, observe the table given that on the screen, that distance traveled by the car in a time interval of 2 seconds. that is given in the table. In table, if you observe table in second and distance in meter is given, and 0, 2, 4, 6, 8, 10, 12, that is table, and the distance in meter is also given 0, 1, 4, 9, 16, 25, 36. And if you draw a graph using these values, we get this type of graph. This is not a straight line graph. It is a it is represented as it is the graph for non-uniform speed or non-uniform velocity, or it is a accelerated motion. This is a graph for accelerated motion. Okay, we are going to wind up your class, and velocity time graph we will discuss in next class. Okay, based on this informations, you have to draw some graph. I am given one of the I am going to given one of the follow-up activity regarding with this topic. Let's do the activity. Okay, based on the position, distance, time graph. And next class we will discuss about the velocity time graph. Okay, thank you for watching my video.